Hey guys, this is Miss Falkenberg. I see you've been gone for a couple of days. We've been working on a motion at a constant acceleration. Now we've been looking at motion at a constant acceleration with velocity time graphs, and they're a really good tool to be able to find out information about motion. For instance, on a velocity time graph, the slope is the acceleration, and then the area. Right, we did that. The area between the data and zero, basically if it says it's 10 meters per second and then 20 meters per second, I guess I should do that the other way for you, over 10 seconds, right, you can calculate the area of that trapezoid of sorts by finding the average velocity and multiplying it by time. And you can find that displacement. So you can get acceleration and displacement and velocity information from a velocity time graph. But what we introduced while you guys have been away and been sick has been more of an equation approach. Now, I know most people love equations, right? But having those velocity time graphs are really important, especially with the AP test, and they can be a lot easier. Ultimately, right, they're going to give us three equations that can be used when there's constant acceleration. First, if you see acceleration equals v minus v sub 0, v sub 0 is velocity at time 0. We could call that initial velocity. And then this is final velocity. So the change in velocity basically over time, which is basically, right, elapsed time. So when I modify this equation, I ultimately get equation 2.6, velocity equals initial velocity times acceleration multiplied by time. Okay, and so they give you a little example here. It'd be good for you guys to read through this since you guys have books at home. The next one uses velocity or average velocity, and we've done this where you add them up and divide by 2. So under constant acceleration, the average velocities when you add the velocities together and divide by 2. The next equation, 2.9 or 2.9, is about displacement. So basically, this is position at time 0, and this is final position. So if I moved, using an algebra skill, this to the other side, that'd be x minus x of 0, or final minus an initial, which is delta x, or displacement. Displacement is equal to the initial velocity multiplied by time, plus 1/2 at squared. And if you notice, it's in the form of a quadratic, which all our motion looks like a parabola. Okay, so you've got equation 2.6, equation 2.7, I guess this is position and time. We've got average velocity, and we got 2.9, which is this displacement equation. And with the combination of these equations, we can get a fourth equation, okay? And that becomes, here it is, equation 2.10. Final velocity squared equals initial velocity squared plus 2 times a times the displacement. So basically, you've got these four equations at your fingertips to be able to solve constant acceleration problems. Now, you need to basically create or do some practice. I always like to list out initial position, final position, initial velocity, final velocity, acceleration and time. And when I read the word problem, I like to try to figure out what are they giving me and filling in the blanks, okay? So it wouldn't be a bad idea to take a look at this, but our acceleration homework 1.11.1 is basically practicing using these. So they talk about known and wanted. If I want final velocity, which equation would I use? I've got my initial position, final position, initial velocity, and acceleration, but I don't have time, so I can't use one. I don't have time. Oh, the only one that doesn't have time is this third equation, initial velocity, acceleration, and change of position. So I could find final velocity using that equation. But you don't know it until you write it down. So take a look at those, practice those. I hope that gives you an idea solving problems, so they'll give you strategies draw a diagram, identify what's known, use the principles of physics, right? Find the equations, try to do the calculation, see if it's reasonable, okay? So they'll give you some examples, but you could apply it to your homework if you'd like. I hope that helps give you an idea what you missed and know that you have a resource in your Giancole book. Okay, we're going to be practicing on Wednesday also. You are always welcome to come in on our Google Meet in 3rd period, 4th period, or 7th period. Okay, bye.